So let us start this question number 3.7. It says a body of mass 8 kilograms slides on a horizontal plane and is connected by a light inextensible string to a suspended body of mass 3 kilograms as shown in the figure. The coefficient of friction that is given. The coefficient of friction, it is 0.3 between the mass and the plane is 0.3. If the pulley is frictionless, determine. You have to find out the acceleration of the system. B part, the tension in the string. Imagine this is T in the string. So then you have to isolate the free body diagram. This is very useful. Free body diagram FBD. So if this block moves to the right and then the tension force is here, the friction force is opposing the movement of this block, mu n. Now it has not been specifically mentioned which mu is that, static or dynamic. The formula is same. Force for friction is mu n. So we will use that, and this is the weight, this is the normal reaction. So this is the free body diagram for this mass 8 kilogram, and for 3 kilogram this is the weight and this is the force due to the string, and no other force is acting on it. So all the forces are equal to mass times acceleration. That's the Newton's second law. So let's apply this second law on mass 8 kilogram. All the forces in x direction. Sigma F is equal to mass times acceleration. T positive minus mu n is equal to ma. This gives me equation number 1. Now what is n? N can be found from the balance of forces in the y direction. Force balance. So one is upward, one is downward. That means n is equal to mg or 8g. You will plug this in over here. 8g. This is 8. So I can, let me write this down here again. T is equal to 8g plus 8a. This a we have to find out. This is equation number 1. Do you understand this simplification for the equation number 1? Right? Now for equation 2, you will use the same method for the vertical direction on mass 3 kilogram. The free body diagram, all the forces are equal to mass times acceleration in the y direction. It's not moving in the x direction at all. You have a question? V? Velocity? Mu. Yeah. You have to write down mu. I forgot to write this down. So mu, thank you for letting me know. Sometimes we make mistakes, we should acknowledge. And now we go over here. Can you tell me, before I write down, what should be the force is equal to mass times acceleration? What are the forces acting on this block of mass at 3 kilograms? W minus T is equal to ma. This is the second equation. W is positive because y positive is in the downward direction. W is positive, T is negative, ma. This acceleration we have to find out. Do we have W? Yes, we have W. MA, and T is equal to 3G minus 3A. Can you solve for this easily now? Yes, of course, we have two equations, two unknowns. So let's find out T from here and plug it in over here. So in 3G minus 3A is equal to 0.3 times 8G plus 8A. What is value of A? Can you guys do me a favor finding out the value of A and compare your answer in the book? In the book it says the value of A is 0.535 meters per second squared. Do you verify this answer from this equation? And once you know that value of A, you can plug it in. Plug A in either equation. Let's plug in equation 2. So the tension, the B part, find out the tension in the string. 3 times 9.81 minus 3 times 0.535. So what do you get? If you solve for this, you should get about 27.83 newtons. Do you get the same answer?